Thanks everybody for joining this morning for our contractor technical training. Today we're focusing on heat pump water heaters. My name is Farhad Farman. I'm with TRC, and this program is brought to you by Peninsula Clean Energy and Silicon Valley Clean Energy. And I think we'll dive right in. Next slide, please. Here's our presenters this morning. Myself, Farhad, on the left there. We have the honor and pleasure of Kevin Clark from Marine joining us this morning. So big thanks to Kevin. He's been doing this a long time, so I'm very happy that he's here. Matt Jones is also with TRC, and he'll be presenting some of the slides as well. Our meat of the content today is with Kevin. So myself and Matt will be here to moderate questions mostly. We'll be presenting a little bit of content, but we're here just to make sure everybody's getting what they need out of this. So, we have a small group this morning. I think that we should, I'd like to encourage everybody to be as engaged as possible. We're here to answer your questions about heat pump water heaters and about electrification in general. So yeah, please feel free to make this personal for you. What is the best content that you would want out of this? For the GoToMeeting platform, I think maybe in case you're not familiar with it, you can open and close your control panel using that arrow at the top left. You can mute and unmute yourself, again, with that orange microphone at the top left. Raise your hand, please, if you'd like to ask a question verbally with your voice. You can also type a question in the chat box, but I'd encourage everybody to actually, use your voice. Just because we're a small group and it'd be great to hear from everybody. And you can choose your audio settings, whether that's computer audio or phone call as well. So we're here today to convey key installation criteria of heat pump water heaters in low-rise residential settings. So Kevin will be going over elements of design, commissioning, and occupant education. We want you to feel well prepared after this to be able to recommend a heat pump water heater to your next client. So why are we here today? California has a 2045 carbon neutrality mandate. And actually that date is probably going to keep coming closer and closer based on what we're seeing federally and internationally. Much of California's electricity is carbon free and will continue to get cleaner over time. So switching to electricity will be a primary approach to achieving that carbon neutrality goal. Local REACH codes are mandating electric appliances. More on that on the next slide. And the state code is actually shifting towards electrification in new construction for folks who have been keeping tabs on where the 2023 code is heading. Existing building electrification is actually going to be likely in the midterm. It's a very tough challenge, to be honest, but if we are to address climate change in any meaningful way, it's a critical step. So this is hopefully going to be one of the first steps for many of the folks on this call in order to integrate heat pump water heaters into your business practices. And of course, we're here to help. We're here to provide trainings. We want this to be useful for you. So please let us know how we can make this useful for you. Please feel free to shout out questions as we go through. So this is the map of REACH codes. Well, it's the chart of REACH codes that have been adopted so far. In the state of California, there's 35 cities, 35 jurisdictions. And particularly for San Mateo, Santa Clara counties, there are 19 agencies that have adopted REACH codes. And there's some variation here in the columns for what the type of REACH code was, but I think that we're trying to get across here that this is not a one-time thing. This is a movement that's going to keep expanding and keep repeating every year. So if we are to, again, achieve our carbon neutral goals, we need to electrify and we need to become familiar and comfortable with heat pump water heaters. Next slide, please. Here's our agenda for today. I'm going to be providing the introduction. I provided the introduction, rather. I'm going to pass it off to Matt to go over some of the value proposition elements of electrification. And then we're going to hand it off to Kevin for the water heating design, commissioning, and occupant education. Question and answer. Actually, we have a dedicated time for this, but at any point, please feel free to raise your hand, type something in the chat box. Kevin has very graciously agreed to accommodate questions throughout his presentation, and Matt and I are also open to that. So don't feel like this is going to be too formal. And then I'll close it off with program and incentives discussions. There's a lot of incentives available for contractors and for homeowners, specifically for heat pump water heaters that I'll be going over. So we'll talk about what incentives are available, how you can get on participant contractor lists and make your name well known for the residential community. And with that, I think I'm passing it off to Matt. Oh, one more slide. Okay. So we asked everybody a question as part of the registration. What's the biggest barrier to heat pump water heater in residential? It came back as cost was the biggest one. Several people said cost. The next biggest one was the installation and the knowledge of how to install. What's that knowledge base? So that's what we're trying to address today is kind of if there's any unknowns to demystify exactly what's happening with heat pump water heaters and actually get into the technical weeds to understand how they can be designed and installed. So thank you everybody for filling that out. All right, now.
Right.
Thanks, Matt.
Hey all. Hey, so I'm going to start this section by talking about why we're having this push for electrification, and then I'm going to talk about the value proposition for you and your customers. So California has been pushing renewable energy for quite some time, and there are two actions that are pushing even harder, and Farhad alluded to these. So one is SB 100 legislation that is requiring carbon-free electricity production by 2045. But meanwhile, an executive order signed at the same time requires the entire economy to be carbon neutral by the same date. So what this means is SB 100 sets up California to have clean electricity, and the executive order pushes the transition to use that clean electricity. This means we're going to see a massive shift from gas to electric, from everything from new and existing construction and also transportation. And why is the state doing this? So climate change has been making California hotter and drier. It's making wildfires more common and damaging. So this is just one of the negative outcomes of climate change that these actions are trying to mitigate. So that's one of the reasons why. And now we have this opportunity to move to cleaner forms of energy through electrification. So where should we focus? Today we're going to be talking about installing heat pump water heaters instead of gas-fired water heaters. And these happen to be the single biggest gas user in California homes, representing almost 50% of the gas use in a typical home. And so not only is it cleaner, but heat pump water heaters are at least 4 times more efficient than their gas counterparts. And because of this increased efficiency, the operating costs are competitive with gas. So that's the benefit for the customer. It's a seamless transition, and it can be even cheaper for them utility-wise if you're comparing to like a basic Title 24 code compliant gas tank water heater. There are some other benefits too, though. So one is if we're switching from gas to electric, there are fewer instances of fires after earthquakes, and electrical infrastructure can be repaired more quickly. Electric equipment is also safer for customers, and it can help improve indoor air quality. And that's because not all the pollutants from burning gas make it up the chimney, so they can cause health problems at home. And that's particularly the case with gas stoves because they don't have flues, but also standing pilot lights on old gas water heaters are a source of indoor air quality issues, which are associated with higher incidences of asthma. All right, so is this push and transition even reasonable? And it is. So California has been moving to clean electricity for quite some time, and it's met most of its targets early. So the market's shifting, it's able to pull it off, and electric homes are not uncommon in the US. So one in four homes currently in the US is all electric right now. If we're looking at water heaters and we look north to Washington State, 50% of the water heaters there are electric right now. So this stuff's out there and totally doable. All right, so what's in it for you? So we're going to talk a little bit about new construction and then quickly about existing buildings. So if any of you guys are involved in new construction, this is a benefit to your customers because you're skipping all of this infrastructure costs that are associated with running lines to the site and then piping gas lines to appliances. It's pretty significant cost that you're avoiding on the new construction side. And then two, building with electric has lower capital costs for equipment, and the utility costs end up being about the same. If the customer's adding solar, they're going to save on their overall utility bills. So this study here, it's showing the added or reduced cost to choose electric equipment over gas equipment in new construction. If we zoom into water heaters, in this particular study, they're expecting heat pump water heaters in a new construction environment to be less expensive than a similar gas tankless water heater once you take into account getting gas to the appliance and things like that. If you're adding solar or your existing customer has solar, then with a heat pump, it's the obvious choice because you need less solar output to run a heat pump than to run an existing electric resistance water heater. And then finally, on the existing construction side, there are some potential revenue opportunities for you. So we don't know what your business looks like, but say you have a crew and you're getting, say, 30 calls per week on gas tank water heaters failing. Electric heat pump water heaters are more expensive. That was something that everyone noted as a survey response. But that's also a revenue opportunity if you can convert, say, 10% of your customers to electric heat pumps. You're going to see overall revenues for your business. So it's more expensive, but for those that you can convert, there's definitely a benefit for you. And that's it for me.
Yeah, I think we have, that was great. Thank you, Matt. We have one question here. What's being done to upgrade the state electrical infrastructure to accommodate more electricity usage? That's from David Crabb. Thank you, David, for that question. It's a really, really good question. I think Kevin points out, first of all, that about half the homes nationwide already use electric water heating. So switching from gas to electricity is not an insurmountable task. California uses about 5% electric water heaters. Now, that said, that does represent an increase in our current grid's demand. And I know that the rolling blackouts or the brownouts recently are on everybody's mind. So I think the answer here, and I'll try to distill it a little bit, and Kevin, you can chime in here as well. Heat pump water heaters alone are not going to be the reason why the grid fails. So our client on this project, Vanessa Clean Energy, performed an analysis, and according to their calculations, if every end use in residential buildings were to electrify, the peak demand, so actually the moment that the peak demand increases because of these electrified end uses, would only increase by 1%, which is a very small amount compared to what the grid is already able to supply. And what that means is that our peak might increase by 1%, but we're utilizing all the rest of the time, we're actually utilizing the grid. We're making use of it better. We're using it more often from that peak capacity that we have. It's actually a better utilized infrastructure and resource that we have. And then I think the last piece I would add is that utilities, our community choice aggregators, the Public Utilities Commission is well aware of the future that we all need to achieve here. So what we're all collectively working towards is a hardened grid, and that means updating outdated infrastructure, and that means allowing for more distributed energy resources, whether that's backup power at the substation level, whether that's utility controlled battery storage to prevent any kind of, or to avoid any kind of downstream effects from upstream power safety shutoffs. There's a multitude of levers that we do have and that we are working towards in order to harden the grid. And I think that if we can get our mind around reducing the amount of investment in a separate altogether energy infrastructure, which would be this piped system, the piped gas system, and instead investing into putting all of our thought and energy into hardening the grid and making that a superb system, that's kind of the goal that we're working towards in the long term. Anything to add, Matt or Kevin?
I would just say, on the water heater side of it, utilities in the state are needing these types of resources, especially on the electrical side, as more renewables hit the grid, because we can't always predict, when the sun is shining and when the wind is blowing. So we need to be able to park energy in a lot of different places. In battery storage, utilities are using heat pump water heaters as thermal storage batteries. That way they can supercharge them in the middle part of the day when sometimes, utility rates for the utility actually go negative. So they're actually paying places like Arizona to take power off the grid because there's so much solar production during that time. Instead, they're going to be able to park thermal energy into a water heater and then shut it off during your peak time. So again, this is going to be a great grid asset to help stabilize the grid to help prevent some of these brownouts or blackouts.
That's great. So David, if we didn't answer your question, please feel free to raise your hand. We can revisit that. And yeah, and any other questions at this point before Kevin dives in? I want to give everybody an opportunity here. I don't see anything in the chat. So I think Kevin, if you would please go for it.
Excellent. Can everybody see my screen?
Yes.
Perfect. Again, my name is Kevin Clark. I work for Ream Manufacturing. As you know, Ream makes a variety of different water heating and air conditioning products, as well as some commercial refrigeration. We're a global company, so we have a lot of reach throughout the world, and we have very aggressive sustainability goals, including reducing our carbon reduction or our carbon output by 50% by 2025, as well as have zero landfill impact on the production of water heating and air conditioning equipment. So a lot of recycling going on. Really do appreciate the time this morning. I know it's tough to carve out some time every day to listen to some of these virtual trainings. We wish we could be there in person, but of course everyone's trying to stay safe during this COVID time. So talking about heat pump water heaters, my background, I started with GE on heat pump water heaters probably about 6-7 years ago. And once that line shut down, I went to Ream. A couple other my coworkers went to Bradford White and A.O. Smith. So we have a good friendly competition. We get together over a beer every so often, just talk about the industry. Of course, no collusion, but just good friendly competition. So the big players in the market, of course, are Ream, Bradford White, and A.O. Smith. They're all good products. They're all within, at least 3 generations of heat pump water heaters since 2009. The ProTerra is actually our 5th generation. So every time we have a switch over, we get a little bit more efficient and a little bit more feature heavy, which I'll cover here shortly. I'm not sure, this is supposed to be intermediary class, so I'm not sure where everybody's at with heat pump water heaters and how they work. Basically, we have a fan that's drawing air across an evaporator to transfer heat into the refrigerant. That refrigerant is compressed and superheated, and then that refrigerant is pumped around condenser coils around the outside portion of the tank to transfer the heat. And that process of moving heat, not creating heat, allows it to be up to 400% efficient. So it's a good technology. It's something that's very commonly used in every single household. That refrigeration cycle is in every refrigerator. It's pulling heat out of the box. It's dumping it at your feet. When you walk by barefoot, you can feel it. Same thing with your air conditioners, just moving heat out of the home, evacuating it at that condenser coil spot outside the house. So again, this is not a scary technology. This is used in a new way. And realistically, it's not even new. It's been around since 2009 for these integrated units. There were some split systems introduced in the 70s. Of course, they didn't have great traction just because of the installation challenges that those present. This is a bit of an eye chart, but it provides lots of information. You guys are going to get these slides to review, but has a lot of different information points. But again, just be assured that these integrated heat pump water heaters have been around for quite some time. They are all very efficient. We operate within $5 to $10 a year between each other. So you don't have to worry if like, hey, my normal brand is A.O. Smith. I'm going to stick with A.O. Smith. I'm wondering if I'm losing out. You're not going to. So these are, good brands all around. They do have, some pluses and minuses for each brand. So, get in touch with someone from either the manufacturer or your sales agency just to find out what those differences are and what's coming down the pike here pretty soon. Physical installation, of course, before you install it, you want to make sure that you're installing the right equipment. A 50-gallon heat pump water heater is not equivalent to a 50-gallon gas. And a lot of that has to do with the recovery. So traditionally with a heat pump water heater, it's going to have long recovery times. That's the way it's going to run the most efficient. So, with a 50-degree rise, so if your incoming water temperature averages about 70 degrees throughout the year, you're going to get about 12 gallons an hour of recovery just with the heat pump. So that means everyone's going to shower in the morning, they leave for work and school, unless they're in COVID land. And then, that heat pump water heater is going to take, 3 hours, 4 hours to recover all that morning usage. And it's going to do it efficiently. It's going to do it, slowly. In those cases of high hot water draw, each of these units will also kick on an element if it's in hybrid mode. And of course, the element's going to produce about 37 gallons an hour with a 50-degree rise. But again, that's only about 100% efficient. The heat pump is, much more efficient, usually about 4 to 5 times as efficient as an element, depending on the ambient air condition. When you take a look at your traditional 40,000 BTU gas tanked water heater, it's only about 60% efficiency, so 40% of that energy is going out the flue. You can get about 62 gallons per hour with that product. So again, it's less efficient, a lot more polluting. Usually you save about a ton of carbon a year going from that 40,000 BTU gas product to a heat pump water heater. So for your customers that are very green conscious, maybe they have solar on the roof, maybe they have a Tesla in the driveway. This is a good product for them. We just have to get it sized correctly. So, we're pretty comfortable saying that 4 people is going to accommodate a 50-gallon, 5 people for a 65, and 6 for an 80-gallon. Now there's some tweaks that you can do to extend the life of the tank, including mixing valves, turning up the temperature. We don't recommend that you turn the temperature above 120 degrees, but maybe show the customer how to do that. It's just typically an arrow up button. That way they're mixing in more cold water, when they're in the shower. That way the life of the tank lasts longer. So you're using hot water slower. For sizing, you also want to not only accommodate how many people are in the house, but how many people can potentially be in the house. So if you have a couple in a 4-bedroom, 4-bath house, putting a 50-gallon in, especially during the time of resale, isn't going to do them service. So you may want to talk to them about upgrading to a 65 or an 80-gallon. That way, when they go to resale, they will be prepared for that. Typical installation, this is a standard electric water heater. There's not much to it. Pretty simple stuff. We make it a little bit simpler. We have 0 space installation requirements, so these can be placed right up into a corner. The only big difference is for you, the contractor, is it's a little bit heavier. I mean, you do have a refrigerator sitting on top of a water heater. So it's about 50 pounds heavier than a traditional tank. It is a little bit top heavy. So if you're getting it up on a pedestal, just be careful to make sure that you're accommodating for that extra weight on top of the unit. And then you can just earthquake strap them in. Other manufacturers check their use and care manuals. Some require an 8-inch service space all the way around the unit. That means you have to channel block and strap the unit 8 inches off the wall, which means sometimes you have to build out the pedestal. Just take a look at the use and care manual to see what those requirements are going to be. The only other big difference that you guys are going to need is this condensation drain management. So it's a 3/4 inch PVC. It can either be converted to flex hose, or you can leave it as PVC, and it can be drained into a floor drain near the water heater. It is non-acidic because this is non-combustible. So a lot of times in retrofit applications, they will punch a hole to the outside of the wall and drain it out into a flower garden. Check with code just to make sure that is allowed. Sometimes they do need like a dwell tank or something to be able to capture that condensation. Again, it's rainwater. This is the same stuff on the outside of your can of Coke. If it's cold, it'll produce some condensation on it. Other considerations are going to be the air exchange. So all manufacturers require 700 cubic feet of space in order to exchange out heat. That's a 7 by 10 by 10 room. If you're in a garage, you're golden. If you are in a smaller closet, then you have to either put a louvered door in, that way it can breathe into the hallway, or you can duct them. And every single manufacturer will have ducting kits and allowances listed in their use and care manual.
Hey, Kevin, we've got a question here.
Sure.
And the question is, I've heard efficiency and capacity falls as exterior temperature falls, say around 30 degrees, so freezing, and that the loss in efficiency or capacity is made up with the resistance heat. Is that the case?
So our shutoff temperature is 37 degrees. Bradford White's is 35 degrees, and A.O. Smith is 45 degrees. So we don't put adaptive defrost cycles on these units, just for affordability. And nobody keeps water heaters in freezing conditions. So we see the sales of these a lot of times in northern climates that are very cold. So even in Spokane, Washington, which has a lot of freezing conditions, they put these out in the garage, and their garages typically stay above 40 degrees even in the winter time because they are insulated. California garages typically don't get pretty close to that shutoff temperature, but if they do, again, you do have the electric resistance backup to provide hot water. Consumers get hot water heaters to provide hot water, so that's why those elements are there. I will say for the efficiency, yeah, there is a drop of efficiency at 37 degrees. Our efficiency is still at about 300% or a 3 UEF for the heat pump. When in the summertime, when it's hot, you know, if you have a garage that's about 100 degrees, I think Sacramento just had a study in a garage where they were getting 6 COP or 600% efficiency in the summertime for their heat pump water heater. So there is a difference. It is still very efficient, especially considering, you know, electric resistance is only about 100% efficient when running. So don't be scared about putting these in a garage when it gets cold in the wintertime.
Cool. And we have another question too. It is, do you foresee a heat pump water heater that will accommodate radiant space conditioning?
Yeah, so that's a great question. I think manufacturers are looking to fill, you know, multiple gaps, both on the commercial and light duty commercial applications. These units are compressors only about 4,200 BTUs, which is about a third of a ton. So doing any type of hydronic heat is just not a good application for these current units. You'll see that change here coming in the future with new products hitting the market. I mean, that's still a very small percentage of homes in California, but you know, you could probably, you know, use a commercial version into those radiant heat applications.
Cool. And then there's a note on this question, and I think either you or Farhad might be able to take it. So it's currently the CEC does not allow a heat pump to be modeled within Title 24 as a combined source for domestic and space heating. So do you guys have any insight in future modeling changes?
I would have to get with the CEC if we did have a product that would accommodate that. I wouldn't recommend our current lineup of heat pump water heaters for that application now anyhow. And it's not because it won't handle it. The electric resistance element will just kick on. We don't want to have you know, such a low efficient product out there when there's good you know, other equipment that can handle that better.
Mm-hmm.
I'm going to add a couple of thoughts here. This is our first contractor training event, and it's focused on residential heat pump, you know, domestic water heating. We're kind of going into space heating now, and we do have another event that we're planning that talks about recirculation systems, predominantly for space heating, predominantly for either domestic water heating, service water heating, or space heating. That should be sometime early next year, I think maybe January. So we'll get into more about those specifics about, you know, space heating and recirculation during that training. So please stay tuned about that.
Perfect. Now I'll say one more thing about condensation management. If you are installing this in the basement or in the central part of the house where there is no drain accessible, you can always get a 2 gallon per day condensation pump and then pump it where there is a drain. A little bit more installation work, you know, but obviously you don't want, you know, 2 quarts of water hitting the floor of a homeowner's home every single day. So there are ways to get around not having a drain source right next to the water heater. And of course, your big, yes.
And I'm sorry, and because you mentioned a couple of things on that last slide, I have to interject with a couple of my questions, if that's all right.
Sure, absolutely.
So you mentioned seismic straps. Would you recommend any kind of thermal isolation, either with the seismic straps or perhaps on the pad even? This is these are questions that have come to me in the past, and I want to make sure what I want to understand your perspective on these.
Sure. So there are some considerations on vibration, and sometimes just the structure of the house for some reason will pick up the frequency from the fan motor and amplify that, and maybe transmit that sound, even though it's not really sound, it's vibration, into other rooms. So if you're not on a concrete slab, if you're on a a studded platform that's connected to the rest of the house, you may want to put a rubber isolation pad underneath just to isolate that vibration into the studs. Also, your earthquake straps, you can get vibration isolating straps. That way, again, you're not transmitting that vibration into the studs and into the harmonics of the house. Not typically an issue. We don't see it very often, but you know, it has happened. So if you have a customer saying, "Man, this thing is super loud," well, it's only 49 decibels, which is you know, lower than a conversation. More than likely, you're transmitting vibration through the studs, and the harmonics of the house are amplifying it.
That makes sense. My next question would be about location and ventilation needs, but I think you have some slides on ducting, so maybe I'll bring it up then.
Perfect. So again, the biggest hurdle that you guys are going to run into, of course, is the electrical demand for these. It is a traditional electric water heater. The reason why you need 240 volts or 208 to 240 volt 30 amp is because of the elements. They are 4,500 watt elements, so UL requires 80% of that circuit, 20% to be not used during that time. That way it doesn't create a toaster effect inside the walls. So that's going to be the biggest hurdle for you. We make a 240 volt 15 amp model, so our elements are 2,250 watts instead of 4,500 watts. So that is also available for you as a contractor. It's basically a single pole 240 volt instead of a double pole. If you are really panel challenged in getting this into the electrical panel. There are some future rebates I'm sure will be covered down the line that will cover panel upgrades when needed going to electrification. So keep your eye out for that. Again, this is going to be probably the biggest hurdle if you do not have an electrician on staff or a general contractor license. Certainly partner up with those contractors. That way, you guys can work together on some of these retrofit projects. Also, something to consider is working with solar installers, because if the solar installer is there, they're already doing electrical at the panel. If an upgrade needs to happen, they can manage that. But also for the value proposition for the solar installer and for the customer is that they will have no water heating costs at that point. So, typically they're going to spend, a couple $100 a year on heating water with gas. That's going to be gone because all the water heat will be provided by the solar panels. The solar installer will get to install an extra 2.5 panels, so they get a little bit more revenue. And because this product is so efficient, it will actually help the payback story for solar on the roof, because it has a much quicker payback than the 8 to 10 years that solar provides.
Hey, Kevin, gonna interject. So you have a 15 amp model, that's great. So what application is that appropriate for? You mentioned it's got a bit of a smaller capacity. What's the tank size, and when should contractors expect to recommend that model?
So they come in all the variations that we make. So we make a 40, a 50, a 65, and an 80 gallon heat pump water heater. So I mean, one thing also to consider in California is water has a pretty high penalty for price, so people conserve it. They have low flow shower heads, low flow faucets. They typically don't waste hot water taking endless showers. Some do. That's probably not the right customer for a heat pump water heater if they're going to take a 2-hour long shower. But typically the usage in California is showing about a 40 gallon per day usage for hot water. The national average is about 64. So at any given time, you have a day's worth of hot water stored into the tank. So, you don't necessarily need that supercharged element coming on all the time. You're going to rely upon the heat pump for the vast majority of recovery. So as long as you're sized correctly for the family and for the house, again, first hour ratings are there. It is lower for 15 amp models because you don't have that element kicking on quite so hard. But if they're energy constrained, they can ramp up the temperature by installing a mixing valve stretching that tank out by 40%.
Okay. So it sounds like it might be a situation where if they have a large family, if they anticipate a high hot water demand repeatedly, every morning or every afternoon, that recovery rate would limit perhaps the hot water availability. But there's ways around it. You can have a larger tank, you can have a higher temperature, and perhaps the 30 amp isn't necessarily a roadblock, I guess, in many situations. Is that?
It may not be. Of course, every situation is going to be different. A lot of times it depends on the age of the house, on what the panel has. I mean, if it's a 100 amp panel, it's going to be hard to put even 15 amps on that panel, and so it just really depends on the situation. But again, there are some rebates out there to help with panel upgrades. There's more coming, from a statewide perspective. So keep your ear out for those.
Yeah, and I'll get into that a little bit. We did get one question here from Mr. David Crabb. What is the anticipated lifespan of a heat pump water heater versus their gas hot water heater? I think plus or minus 10 years. I think if you just speak generally to that.
Sure. So all the manufacturers have 10-year warranties on this product. So they have upgraded anode rods to help preserve the life of the tank. Ours is based off of our 12-year platform. So, really they're designed to last, at least 50% longer than that 12 years, so 18 years. Water conditions are going to be, a big determining factor because we know people don't flush their tanks. People don't change their anode rods. So it's, water conditions are going to be probably the biggest limiting factor. But if you're in good water condition area, these things are really going to last like a standard electric water heater, which is 20 years. We see that up in the Northwest where they have very clean water, non-acidic water. It's typical to have electric water heaters last for a very long time. This is a very simple compressor and evaporator. So, how many refrigerators are sitting out in the garage running for 6 hours a day, keeping the drinks cold? So those refrigerators in the garage are, typically 20 years old. So, again, the sealed system is not really the limiting factor for these heat pump water heaters. It still is the tank life. So hopefully that answered your question. So if you are in a closet, and you need to duct the unit, there are some differences in ducting. We can allow up to a 5-inch reducer, so making 5-inch exit holes is easier than making 8-inch exit holes. Typically, we see ducting in multifamily, where they either want to mitigate sound because the water heater is sitting in the master bedroom closet, or for security purposes, they don't want a louvered door to be able to breathe into the outside. They might have their air conditioning equipment in that closet or some other type of equipment. So we don't see ducting very often, but when it happens, it can be allowed. We have a 2-speed fan in our unit. That way we have a pretty good run lengths, both on flexible and rigid. If it is in an internal closet, typically we see a louver door or, a cutout above the door. We see a lot of times that needs to be about 250 square inches of rating for either the louver door or the cutout. So that way it can exchange air out into the hallway. Any questions on ducting? This is something we don't necessarily need to do in the garage. The garage applications are great just to plop down and leave. Some people get a little, they want to maximize the energy efficiency. Maybe they'll duct into the attic and then return that cool, dry air back into the attic for energy efficiency as well.
I know I've gotten a question before about whether the water heater could be located in the attic or the crawl space. Does ducting allow for that, or is it really a kind of a height issue?
Yeah, I mean, you have to obviously accommodate for the height of the unit plus 6 inches on top to replace that air, or not replace, but to clean the air filter once a year. although we do have, leak detection and a shutoff valve that's built into our unit, it is kind of frightening to have, a storage of hot water up in the attic space, and these things will eventually crack and leak and rupture. So we don't see very many attic installations. We see that mainly in the southeast, but it can happen. They're just heavy. I mean, they're 50 gallons are about 180 pounds. So you're going to have some sort of, pulley system to get it up into the attic safely. So recirc systems, we were talking about hydronic heat earlier. A recirc system is basically hydronic heating. It's not very energy efficient, especially if you have long run times in that recirc pump. So we definitely recommend the push button types that are, demand activated recirc systems. You can confuse the water heater a little bit because all of a sudden you're pumping in cold water, and then eventually that water is going to warm up very quickly. So you can put in a cold water slug right in the middle part of that tank. There are sensors throughout the tank. It's going to pick up saying, something's going on here that I don't understand. I have warm water in the bottom. I have warm water or hot water at the top, but I have cold water in the middle. The unit's not functioning correctly. So that's why we do recommend putting the heat pump water heater in a high demand mode if there is a recirc system. If it's push button activated, I definitely would recommend having at least an energy saver mode, which is our hybrid mode for those recirc systems.
And Kevin, I would imagine the push button concept is so that it's not running all the time. Would a timer also work so that it runs once in the morning or once in the evening, kind of achieve the same thing?
Right. And then, yeah, you definitely want to shorten up those timers if you are in a timer-based system. In new construction code now, it has to be push button activation. So you're going to see a little bit more of those systems in the marketplace for the next few years. Mixing valves, as we talked about, you can increase the capacity of the tank going from 120 degrees, which is what the unit is tested at, up to 140 degrees. It sounds a little counterintuitive, but if you increase the tank temperature, the unit will run more efficiently, especially if there are times of the day that the element is kicking on. It's allowing the heat pump to do more of the recovering instead of that element. So you can maximize efficiency by ramping up the temperature. Again, if you're going to set it above 120 degrees, I would not recommend that. Have the customer do that. And then if they do want to maximize the hot water volume out of their tank, you can add a mixing valve. Of course, if there's hard water conditions present, you want to make sure there's a softener or a descaler that's installed into the system. That way that mixing valve doesn't have issues down the line. Training, there's lots of training opportunities. You can always contact myself or one of my counterparts, but all manufacturers will go to market with sales agencies in California. Mega is our rep agency. A.O. Smith has Paramount and Delco. Bradford White has Rep West and Signature. You can attend an online training course through any of the manufacturers. Those are listed there to the right. Typically, we have Innovative Learning Center up and running with 2 sessions every single week with about 20 plumbers at a time. We talk about our most efficient products out there, kind of wine and dine and have a good water heating education experience. We'll get back up and running once some of these restrictions lift next year. So we look forward to having you at one of those training sessions. And then lastly, the mode of operations for the heat pump water heater. We have 5 modes, some have 4. Energy saver, which is our hybrid mode, is what the unit is shipped and tested at. It's going to traditionally use that heat pump, which only gives about 1,700 watts of equivalency. It's using about 300 to 350 watts to get it. So that's where the big efficiency comes in. In situations where there's high draws of hot water, the element will kick on, so you get 4,500 additional watts. So at that time, you're getting 6,200 watts of recovery. And you know, again, that's getting pretty close to what a 40,000 BTU gas water heater gets. So, you know, you're about 10 gallons off, but still it's almost equivalent for those high draw situations. You can put it in heat pump mode, that way it's locking out the element. Again, that cutoff temperature is 37 degrees. You typically won't see that in California. You will see it if you lock this thing up in a closet that's not very big, and then there's no louvers or ducting. It will draw that temperature down in the room below 37 and shut off and turn the element on. If you have company coming over where you know that you have, you know, an additional family hitting the house, you can put it in high demand mode, which will always have the heat pump running, but it'll kick on the element a little bit sooner. That way it's going to satisfy consumer comfort when there's a lot more draw on the system. Don't really use electric only mode very often unless there's something wrong with the heat pump. Again, our warranty is if anything happens with the heat pump, we will replace the unit free under warranty. We obviously don't have very many of those because we wouldn't be able to sell the product and keep it up and running. So pretty bulletproof sealed system. You don't have to work on it. Other manufacturers sometimes do require the customer to crack open the yellow pages, find an HVAC contractor to come out and work on a water heater, which we know is somewhat challenging for the consumer. And of course, vacation mode, you can take up to a 4-week vacation. I wish I had 4 weeks of vacation, but they don't give that to me. So I wanted to go a little bit more into what we have to offer, which is the ProTerra. So the ProTerra, again, is our 5th generation heat pump water heater. We're really going to have, you know, 3 main attributes, being smart, sustainable, and provide savings to the homeowner. I'm going to skip that video because a lot of times they don't play well in these type of applications, but certainly check out ream.com/hybrid, and you can take a look at that video. It is also a YouTube video where you can show the consumer, just to give them an idea of what a heat pump is and how it's going to save money. With this generation, we did continue with the leak sense, but we also added leak guard just to take it a step forward. So not only do we detect the leak, we prevent the leak. We prevent that leak to only about 20 ounces of water. Very much like when you put your finger over the straw and pull it out of your drink, that water stays in the straw because of the vacuum created. Same concept goes here in a cracked tank. If you have that water shut off, and as long as all the valves in the house are shut off, it will hold that leak to about 20 ounces of water. Every unit has built-in Wi-Fi. The customer can download the free app to have additional functionality, including remote control. They can get compressor and element health alerts, as well as check to see how much hot water is left into the tank. So if you do have a large family coming over, everyone's showering, not quite sure if you're going to get stuck with a cold shower, you can actually open up the app and find out if that's going to be the case. We're going to have a lot of sustainable features. Of course, this is the highest efficient product out in the marketplace today. You're going to reduce carbon, you know, again, about a ton going from a gas to electric per year. So it does have a pretty big carbon reduction. You'll be able to track energy usage on the app. And of course, all these heat pump water heaters are going to be Energy Star rated. And the reason why people, you know, make the switch is it is going to provide savings. If you are installing this in a customer's house that has solar, again, they're going to pay $0 to heat water all year long. We already saw on that energy scale that water heating is 49 or about 45% of the usage of power in the house. So you're taking half of that power right off from the get-go, which is a great savings. If they don't have solar, because the efficiency of this product, you will save some money. It's not as much as if you had solar, but it will have a little bit of a payback story going from even a tankless to a heat pump water heater, especially when you enable the scheduling feature that's built into our app. So this is how the app looks. Again, you can get into usage reports, scheduling, the health alerts, set the water heater. You basically have all the functionality and plus some as you would just looking at the control board. If you are an attic, this is a great application because you can change the temperature and mode of the water heater without actually being right at the physical site of the water heater. Contractors can also input their contact information. So if there is a service alert, if your contact information is in the app, the customer can just forward over the alarm codes to you. That way you show up to the call prepared with the parts you need to make the repair. We talked about utilities controlling these, using them as thermal storage devices. We have both our EcoNet communications platform, which is already built in, but we also have a built-in CTA 2045 connector. That way they can ship the homeowner a module and enroll them into a demand response program. They're going to get additional savings because they're going to schedule this water heater around time of use peak rates, as well as be able to provide high levels of consumer satisfaction. The Midwest has been shutting off water heaters from 3 p.m. to 8 p.m. every single day for the last 40 years. And the retention rates that the co-ops get in those areas are very high. So when you start to mess around with the thermostat, people get a little bit cranky because all of a sudden you're making it uncomfortable. But when you shut off the water heater for a period of time, consumers don't feel it. There is a storage of hot water to get them through that peak time in order to have those controls and benefit society. Of course, the utility is going to pay the customer for that service as well. J13 is like a new construction benefit for builders. It's basically throwing a schedule on without the unit being connected to either Wi-Fi or cellular. So it is something that's coming down the pike. So if any of you do new construction, keep an eye out for that. Also, our tier 4 models are giving 2 times the benefit as condensing tankless, which for a builder, that's about an additional $600 value in measures they don't have to use somewhere else in the house. We have a lineup of the Builder, the Proterra, and the Proterra with leak guard. The Builder is a tier 3 rated product. The Proterras are rated at NEA tier 4. That just means they're a little bit more efficient. They're going to get you a little bit more EDR credit or energy design rating credit for new construction. They're all quiet at 49 decibels, and they all have built-in Wi-Fi health alerts. The hybrid Builder will allow an addition of leak detection, where the Proterra you can add in leak detection and leak guard. Of course, the Proterra with leak guard has everything built in out of the box for you. Lots of different variations. We have, again, 16 variations, both in the Rheem line and the Rude line that's out in the marketplace. Again, you will have access to this slideshow to review first hour delivery recovery rates. And again, the recovery rates are on a 90-degree rise, so you typically won't see that in California. Of course, our Builder lineup as well, in the 40, 50, 65, and 80. So that's pretty much what I had. Are there any questions I might be able to answer?
Hey, Kevin, yeah, we have one question. How does the first cost for a heat pump water heater compared to a gas water heater?
So gas water heaters in California, typically are a little bit more expensive because of the ULN requirement. So I'd have to look at what the cost is. I want to say it's about $600. Does that sound about right? So you're looking at
right, yeah.
So about a $600 water heater replacement, as opposed to a 50-gallon out of Home Depot is going to cost about $1,300. Again, your local distributor is going to give you your price, which will probably be below that. we don't set pricing, so that's kind of hard for us to say where your distributor is going to land on cost. So still you're looking at about that $700 delta. We're going to talk about incentives here in a little bit to help reduce that first cost. But for consumers, what they really have to be prepared for, again, this is a moving train. It's already started. We have to electrify everything. You already heard from the governor that electric, new cars, new internal combustion cars won't be sold in the state of California by 2035. You're probably going to see that in water heating as well before that time frame. New construction, again, I just mentioned that builders are getting a $600 value by putting in a heat pump water heater over a tankless. Next code cycle in 2023, it'll probably be required. So there's lots of moving pieces that are setting up the industry and the marketplace for heat pump water heaters because it is such an efficient product. It's going to be a valuable grid asset for the utilities, and it's still going to provide savings for the homeowner.
Is there ever any need to replace refrigerant lines on these units?
Now everything is it is a sealed system. So if anything goes wrong with the sealed system, so that's your evaporator, your compressor, your condenser lines around the outside of the unit, we will provide a free unit under that 10-year warranty. We are designing these things not to have service ports, which sometimes leak over time. You'll probably see a little bit more of a recycling effort when these things come to end of life. That way you bring them into your appliance recycler, either that or the distributor does, and the refrigerant is recycled at that point. But no, this is 100% plumber serviceable, so we do not require plumbers to have HVAC cards to work on a water heater.
Got it. What type of refrigerant are you using?
All three of us use R134A. So it has a pretty good heat transfer value at normal ambient conditions. So there are future regulations on refrigerant coming down the pike, both for 410A and R134A. So we'll make those changes as the industry calls for it.
Cool. There is a question about if there are any special considerations in recycling a gas tank or a gas water heater.
Not for gas. I mean, again, you're going to drop it off at your distributor, and usually they just take them to a recycling center. But for this type of appliance, because there is refrigerant in there, we are seeing more and more recycling programs being set up either by the local community or the utility. That way the refrigerant isn't evacuated up into the air, which obviously has a negative impact on global warming. It's a very small amount of refrigerant too, by the way. It's a little bit more than what your refrigerant has, or your refrigerator.
Got it. Does Rheem have experts available to help contractors decide what equipment is appropriate for retrofits based on their specific conditions? And does it cost money?
So, I mean, we obviously have our, tech line. You can contact the sales agency. They are pretty versed in this as we start to train the whole market. Again, this is a new product for the market. So sales agencies are our boots on the ground. You have my contact information up there. Sometimes I'm either traveling or doing trainings like this. So if you give me an email, I'll get back to you as soon as I can. Sales agencies, distributors, call lines, there's lots of different ways to get answers. If you register for my Rheem account, not only are we going to give you rewards points for installing products like this in tankless, you will have access to training videos. We can get you service manuals, everything that a contractor is going to need to be able to go to work. If you don't have a website, we give you a website for free for a year. truck wraps. We give you fleet truck discounts on MyReam. So there's lots of value just by connecting with us. And every manufacturer is going to have some sort of rewards program for selling products like a heat pump water heater.
Yeah, and I'm sure for the other manufacturers that both the manufacturers and their sales agencies would be good resources for retrofit questions.
Yeah.
That is, I think, all we have right now.
Yeah, all right. I'll dive in. I think we're at a good time to dive into the incentives here. So I will share my screen. If I can figure out how to do that, let's see here. I gotta make myself presenter first. There we go. Okay. Okay. Can folks see my screen?
I can see it.
Yes, I can see it.
Okay. Took a second there. All right. Programs and incentives. Thanks very much, Kevin. I hope you can stay on the line in case there's more questions that come up for you. Okay, so here's the list of incentives that BayREN put together for everything that's available throughout the Bay Area. So I'll describe BayREN a little bit on the next slide here, but I just want to present this right up front. BayREN themselves, they have two $1,000 incentives available for heat pump water heaters for qualifying equipment, and of course there's eligibility criteria that's necessary there. I want to point out that there are several entities that are providing incentives for heat pump water heaters, and there's even two that are not on this list, one being Sacramento Municipal Utility District. They provide incentives for, I believe it's $5,000 for new construction all electric homes, including heat pump water heaters, obviously. And Peninsula Clean Energy, one of our supporters for this program, is going to be coming out with heat pump water heater incentives as well. And the key, one of the key things to keep in mind is that the BayREN incentive here for the Home Plus has that star next to it. This can be layered. This $1,000 can be layered on top of other programs, assuming that the installation is eligible for both programs, which is predominantly a qualifying equipment criteria. But so you'll have $1,000 from BayREN, and you can have $1,000 from this Future Fit program from Silicon Valley Clean Energy, for example. I've provided this list. This is the source of this list, so you can visit the website yourself. But a little bit more about what BayREN does. So BayREN stands for the Bay Area Regional Energy Network. They serve 9 counties in the Bay Area. They administer these two programs that include heat pump water heater incentives that are $1,000. And as I mentioned, they pair with other incentives, and they also maintain participating contractor lists. So if you go through an application process, then you can actually show up on one of their lists. They will share your information with prospective homeowners that would like to undergo a retrofit. They also have upcoming training events. So I'm going to dive into these last two details a little bit more. So for the BayREN heat pump water heater incentive program participation, you can access this information on bayren.org/HPWH. They'll provide you with your eligibility criteria and the site eligibility criteria and the equipment eligibility. And once you are familiar with the eligibility criteria, you go through a participation agreement, and then you can apply for incentives. In BayREN, not only do they have this participating contractor list, but they also have collateral that you can share with your prospective clients, where it familiarizes heat pump water heaters for you, to them. Why would I install a heat pump water heater? How can I find a qualified contractor? How do I know when I have a qualified contractor? There's several resources available on their websites. I highly encourage taking advantage of the heavy lifting that Beharen has already done to demystify this for your prospective clients. This is what their participating contractor list already looks like. On the left, that's Behran's. City of Palo Alto has their own list already, and here's the source here. I just want to encourage everybody to understand that you can also get on these lists and have your services be marketed to prospective clients. Behran also has a second program, Home Plus. This is not just heat pump water heater program, although it does have incentives for heat pump water heaters. Again, you can go through their website and register, sign a participation agreement, certify that you have the appropriate insurance coverage, and then to become a Home Plus participating contractor, you actually have to obtain a Building Performance Institute certification. So this is probably more appropriate for, and there's Behran staff on the line who are willing to correct me if I'm wrong or answer questions that other folks might have. But to attain BPI certification, I would think that is most appropriate for general contractors. And yeah, then there's onboarding trainings that you would go through in order to land on their participating contractor list. Here's some of their upcoming events. I think on the right here, I want to focus first. So on October 28th at 4:30, they're providing a 1-hour webinar, provides an overview of both the programs I described, Home Plus and the Heat Pump Water Heater Incentive Program. That's actually both on October 28th and October 29th. If you want to mark your calendars right now, that's a good idea. Then for contractor training for code compliance. So outside of administering these two programs, Behran also administers trainings for building departments, but also they're expanding now to contractors as well. And this October 29th, 3 o'clock training event is focused on code compliance. And they're going to go through issues like permitting, inspection criteria, code compliance pathways, and all those different nitty gritty. So we highly encourage you to know how to install these things according to code as well. Here's another program I'd like to highlight. It's the Silicon Valley Clean Energies program. It's called Future Fit. Silicon Valley Clean Energy is the local nonprofit clean power provider, and they provide 100% carbon-free electricity. Their Future Fit program has rebates about $1,000 to $2,000 plus $1,500 if you can demonstrate that a panel upgrade is needed, plus $1,500 if the customer is low income on a low income rate. So this is quite generous. And then one more generous aspect of their program that's going to be coming up is that they'll have online what they're calling asynchronous training resources. So it basically means it's online. You can do the training whenever you want to, whenever it's good for you. And they will actually pay you to attend these trainings. If you are a qualified contractor, meaning that you are performing the work within their service area, or you actually are physically located yourself within their service area. So more on that, please stay in contact, and we'll share this as it comes out. If you want to be a participant in Future Fit, you can reserve a rebate. This is actually at the bottom here. This is the reservation tracker. The last time I checked, there were already a few hundred reservations for rebates on this list. After you reserve your rebate, you start the project, and then you submit the rebate request, and then you receive the rebate. And more information is available here on svcleanenergy.org. Here's how you can stay in contact with us. If you go to allelectricdesign.org, we have lots of resources. This is a program that is inclusive of contractors, but also the development community as a whole, developers and design engineers and architects. We have a highly qualified world expert list of electrification experts that the development community has access to. So we're trying to spread the word that if somebody's having challenges electrifying their project, they can reach out to us, and we'll help the best we can. And this is free technical assistance. We also have design and product guides where we're holding developer roundtables. There's one coming up next month, and the future contractor trainings that we'll have will focus on heat pump space heating, central heat pump water heating, and electric vehicle charging infrastructure. And at the very bottom of this website, there is a spot where you can sign up for future events and add yourself to our list so that we can make sure to keep you informed as new developments come out. So please visit that website, sign up on our mailing list, and we'll be very, very pleasured if you could, and feel privileged if we can stay in contact with you going forward. I believe this is my last slide. I'm going to check to see if there's any questions, or Matt, could you let us know if there's any questions on anything I presented?
Yeah, hey, Farhad, I don't think there are any written questions, but we have a few hands raised. And so, Casatalia, I'm going to unmute you. Heads up, you should be unmuted.
Oh, thank you. I had a question that was answered by Matt. I asked a question during his presentation, but thank you. I get everything that Farhad just mentioned.
Perfect, thanks. We also have a question from Melanie, and hopefully you should be unmuted.
I had the question about recycling the existing gas-fired heater. I was also,
perfect.
yeah, I was wondering also if someone was going to switch over from their existing gas-fired to the water pump, is there any other alterations that need to happen within?
So, again, your gas line needs to be capped, and that's going to vary a little bit by code what that means. Sometimes you can cap it at the site. Sometimes you have to cap it at the meter. So that you just have to double check with local code. The biggest thing that you need to do is make sure you have power, which is that 240 30 amp service or 15 amp service. You need a condensation drain. So, again, if you don't have a floor drain handy, you can punch out to the outside flower garden, and those flowers will get an extra couple quarts of water a day.
Great, thank you.
All right, and then we have one more from Santiago. So Santiago, I'm going to unmute you, or at least I'll attempt to. So you might be muted on your end, I think. Farhad, if you can take a look, I can't seem to help Santiago ask his question here.
Hello, can you hear me?
Oh, we're with you. Hey.
Oh yeah, no, my question was what refrigerant it uses, but you guys already answered that question.
All right, perfect.
Thank you though.
Great. Any other questions?
I don't think so.
All right. Okay, so I think the last thing I'd like everyone to do is please fill out a survey that, we're a small shop. This is our first training event on heat pump water heaters. We want to make future events more catered for everybody here. Please let us know how we could do better. I think there's about 10 questions on this survey. Let us know who you are and what you would like to see next time, or what was missing potentially this time. It really go a long way to ensure that we're helping the market get to where they need to be. So thanks everybody for attending, and please fill out the survey. And thank you again so much to Kevin for joining us. That was very, very helpful. Your expertise is much appreciated.
Well, thank you so much for having me. Look forward to future events.
Hey, Farhad, we have a couple last-minute questions.
Yeah, great.
So one question is, for the smart heat pump water heaters, what has been your experience with mixing valves? Do you always need to have one?
No. Again, a lot of times you need mixing valves to be part of a utility program. that is going to superheat the water heater during the middle part of the day. You want to have that mixing valve just as a liability check for the manufacturer and for the utility, just to prevent scalding. You know, for the contractor, you guys never want to set a water heater above 120 because that puts the liability on you. So in order for the utility to be able to superheat it, use it as a battery, mixing valve is usually required. Again, adding an extra piece of equipment like this will add some service there because scale will form when there's a rapid cooling. So when that cold water is introduced at the mixing valve and cooling that water down rapidly, if there is scale in the water, it will start to harden up around that valve. So, you know, we have a program running right now in Phoenix, you know, has probably some of the worst water in the country. And, you know, mixing valves are an issue there.
Right, so it sounds like the situation is, when do I install a mixing valve? Perhaps it's a situation where I can only install a 15 amp, a water heater that requires only 15 amps, and I want to elevate that temperature. And if I then need to install a mixing valve, then do I have a hard water treatment that I can apply in the tank? And I think you touched on the treatment options as well a little bit. But
yeah, you know, kind of like your tankless. So there's, you know, descalers, or you can just do a, you know, depending on what's allowed in your market. You know, sometimes water softeners, especially the salt ones, are limited by jurisdiction because it does put brine into the wastewater. So, you know, some sort of, you know, descaler or a softener would be recommended if you're using a mixing valve. Not really funny, but the good part is because so much of the recovery is done by the heat pump and the condenser coils around the outside of the tank. There's not very much scale present in heat pump water heaters because that element usually collects that scale, and the element really isn't energized very often. In fact, the lower element is pretty much shut off because it's a NEA Tier 4 rated product.
All right, now I think that's it.
yeah,
That's really good.
yes, all right. Again, please stay in touch, and thank you everybody for joining. Thank you again to Kevin. Thank you, Matt, for sharing your knowledge as well. Okay, if we're good, then I'll close the meeting. Thanks everybody, and have a great rest of your day.
Thanks. Bye-bye.
Take care.